Hello everyone, welcome back to my YouTube channel, and this is Netra from Sri Venkateswara College of Engineering and currently pursuing the fourth sem in a CSE Data Science department. Today I come up with a new topic which is related to a microcontroller, and the topic is software interrupt instruction in microcontroller with a using an example. This is related to how the software interrupt can be installed, or what are the practices, what are the advantages, what are the disadvantages, should be explained in this topic. And the firstly is the introduction part. The software interrupt instructions are used in a microcontroller to trigger a specific function or a routine within a program. And these interrupts are initiated by a software rather than external hardware signals. Like this interrupts can be initiated or can be done by using a software instruction or software signals rather than using a hardware ones. They provide a way to efficiently handle the asynchronous events in a real-time applications. It's used to solve the real-time, real-world problems. And now let's know about the types of software interrupts. It should contain a main two types, which is maskable and a non-maskable interrupts. And the maskable interrupts can be enabled or disabled by a programmer based on the priority of our interrupts. Like if the priority is high, then it should be enabled or disabled in a maskable interrupts by the programmer. And in a non-maskable interrupts cannot be disabled or and typically reserved for a critical system function. And it's like by using a priority order we can enable or disable in a maskable interrupt, but it should not be done in a non-maskable one. So the implementation of a software interrupts in a microcontroller software, like in MC, software interrupts are usually implemented using a specific instruction set such as INT, call, or BRK. By using these three main sets, we can implement a software interrupts in a microcontroller. When a software interrupt is triggered, the program counter jumps to a predefined interrupt service routine to handle the interrupt. This is the function that could be done while while implementing the software. The ISR typically includes the necessary code to process the interrupt and return to a main program flow. Like it should accept all the necessary code and created a new main program in the maximum flow. And the next topic is benefits of a software interrupts. Like software interrupts allows for efficient handling of events without the need of external hardware triggers. As I said before, it should require a software interrupts, not an hardware one to trigger the implementations. They enable the MC to respond quickly to a time-sensible task and real-time events. It's like it should require the less time than using other interrupts, other MCs in this one. By using a software interrupt, the program can be structured or instructed in a modular and organized manner. It should be in a organized in a module-wise manner. These are the main three benefits or main advantages for using a software interrupts. And the example which I try to give for the software interrupt instructions, like let's consider an example where a MC is running a real-time clock application and the software interrupt can be triggered every second to update the clock display, and the interrupt service routine would increment the second counter and update the display before returning to the main program loop. These are the example that I like to give for the software interrupt instruction. And the code which is related to a clock display is this, which is a simple one, which is written in a C language, like a C programming language. It should consisting of a main void interrupt and ISR code, and it should contain a interrupt service routine code and also a updated clock display. And in this example, the ISR function is defined as an interrupt service routine that handles the software interrupts, and it should be written by using a third bullet. It's like it consisting of four main bullets, one, two, three, four, and it should be done in the three bullets. And the next is enabling of a software interrupt. To enable the software interrupt in MC, the interrupt vector table need to be set up. First, we need to set up the interrupt vector table before enabling the software interrupts. And the interrupt vector table contain the address of ISR function for each interrupt source. After installing, after setuping of a interrupt vector table, we need to fill the table with the address of ISR function for each interrupt source. And the programmer can configure the priority and handle for each interrupt in the vector table, like by giving a priority order. Like as I said, if it has a high priority, then it enables the function and enable the programmer to develop a code. These are the main how to enabling the software interrupts. And the best practices for using a software interrupts are like careful handling of software interrupt is essential to avoid the conflicts and ensure proper programming execution. And keep the interrupt service routine short and efficient to minimize the disruption to a main program flow. And test and debug the software interrupt login thoroughly to ensure the reliable operation of a microcontroller. These are the three main practices which should be done by using a while using a software interrupt. And finally, I concluded this topic by these points, like a software interrupt instruction in a microcontroller provides a powerful mechanism for handling asynchronous events. By implementing the software interrupt effectively, developers can create a responsive and efficient real-time applications. And by understanding the types and the implementation and the best practice of a software interrupt is a crucial for successful microcontroller programming. These are the three main important topics that I done in this presentation, which are very useful to solve a real world problem and provide a solution for those problems. And by this, I conclude my today's session. And thank you for watching. Keep subscribing my YouTube channel. And thank you.